Alright, we're going to do question 3, which we are supposed to write the actual insertion sort code. Okay, so write code insertion sort to perform an in-place insertion sort. You may use some of the code from shift list to perform the insertion sort here. Okay, so I'm just going to write this code over here. Okay, so what I've done is that I put in the test case first here. So this test case is what you're going to do. So you can see that, remember when we do insertion sort, we assume that the first item is sorted. Right, so we start comparing from index 1. So the first item to be inserted is 21, followed by 60, then 16, 42, and 19. Right, so that means our while loop will have to start, our for loop will start from here, start from 1. Okay, so that means we write out the first. Okay, before that we also need to check for some of the cases where I don't need to do a sort. I don't have to do a sort if my list is empty or contains only one item. So that means I can do if len list is equals to less than or equals to 1. Okay, I can return the list per se. Okay, I don't have to do anything else. Right. So once that is done, next one. Okay, so now I will do my for loop. Okay, so for I in range from 1 to len this. Okay, so this will cover from here all the way to here. Okay, so now I will do my while loop. Okay, while loop here, right? Remember to decide, okay, you will stay in the while loop as long as you can perform a swap. Okay, so 54 21 in this case I can do a swap. So as long as the left hand side is bigger than right hand side, I can keep on going. Okay, so this is currently I, 21 is at position I, so 54 is at -1. Okay, so -1. Okay, so I -1. Okay, so it means the condition I'm looking for is while, okay, while list I -1 is larger than list I. Okay, and the smallest I can go. When do I stop checking? I will check until my I becomes 0. Okay, but because remember here I'm doing I and I -1, right? So if I cannot let my I drop to 0, if I let my I drop to 0, right, then I -1 become -1, which is not what I want, because -1 will index the last position. So I need to make sure that I doesn't drop to 0. So I do I less than, I must be greater than 0. Okay, so these are my conditions. Okay, so if this portion is true, that means I'll do the swap. Okay, if this portion is true, and of course this must be true as well. So this is true, I swap, right? So that means list I plus 1, comma, list I equals to list I, comma, list I plus 1. This I minus 1, sorry, what I'm doing? -1. Okay, -1. So that's the comparison make. Okay, then once that is done, right, so this will swap until either one of these conditions are not met. Okay, but we also need to, so once let's say we are looking, if you just do a next time for this one, it's just copy paste and just see what happens. So if I run this sort, right, after the first round, it will become like this. Alright, so just type it here first. Control C, it will become like this. Okay, so become 21 and 54. Alright, okay, so now my 60 needs to come in, right? So I need to, okay, so 60 is fine, this one. Okay, 16, right, the first swap here, right, 16, after it comes here with 60 you will swap. Okay, then I need to reduce my I by 1. Okay, if not, otherwise my I will always be stuck at in this case will be stuck at 1 lah. Okay, which is not what I want lah. Okay, so I need to, do I need to decrease I? Let me try and see. Yeah, need to decrease I. So I equals to I minus equals 1 lah. Okay, then so that's all for the code. Then you can just return list. Alright, so let's check whether this works or not. Okay, let's check and see. Okay, so it seems okay. Okay, so what if you don't? That's why we mentioned I must not go down 0. If you set I equals 0, right, this is what happened lah. 60 and 16 will swap. Okay, so this is, I think in class we have talked about this before, so I'm not going to go to detail about why this is the case. Right, so let's keep it as it is. Okay, that's all for this question 3.